This is lesson 5.3a in your Algebra 2 notes starting on page 7. We've been talking about graphing parabolas using the standard form, and today we want to talk about how do you graph parabolas using the vertex form. There are two ways to write, so just a quick review for us. Standard form is when you have y equals ax squared plus bx plus c. So those are all coefficients in front of your terms. But today, vertex form, this one will be y equals, and then you'll have a couple of different things in here. First of all, you will have an a value. Just like you have an a value in your standard form, a leading term. This tells you whether it opens upwards or downwards. You're going to have an h, and you're going to have a k. The h value tells you how you shift side to side. So when h comes out to be a positive value, the graph shifts to the right. When h is negative, the graph shifts to the left. When k is positive, the graph shifts up. And when k is negative, the graph shifts down. The vertex, and this is why we call it vertex form, is simply h, comma, k, which is really nice for us because we just look at it and we pull them straight out. Notice, please, that there is a negative sign in your equation that does not play out in your vertex here. We'll talk about this in some of our examples. The axis of symmetry, remember the axis of symmetry and the vertex always fall on the same line. So if the vertex is at h comma k, the axis of symmetry runs through that at x equals h. So what does this look like? Well, it looks like this. Here's an example. First of all, we want to identify the vertex, so we look at the point inside the parentheses, but we have to pull out the opposite of that. See how it says opposite of h up here? So opposite of 2 is negative 2, but then the k on the outside is positive k. That doesn't change. It stays whatever it is. It happens to be negative 3, so we leave it a negative 3. The axis of symmetry runs through the vertex, so the axis of symmetry is at negative 2. And then the y-intercept, we can't just look and find it like we did before. We need to actually plug in a 0, because remember that's what an intercept is when it crosses the axis. So plug in a 0 to our equation and see what we get out. So we'll say y equals 0 plus 2 squared minus 3. So 2 squared minus 3, which is 4, minus 3, which is 1. So 0, comma 1. So on our graph, we will say axis of symmetry runs here. X equals negative 2. And the vertex is at negative 2, comma, negative 3. Y-intercept is at 0, comma 1. So this tells us one of our reflection points over here. 2, 3, negative 4, comma 1. And then we have to get one more point and reflect it, so we have our total of 5. We've already used negative 2. That gave us this. We've already used 0. So let's go ahead and let's just use negative 1. If we plug in a negative 1, y equals negative 1 plus 2 squared minus 3. We end up getting 1 squared minus 3, or 1 minus 3, which is negative 2. So negative 1, comma negative 2. Here's our point, negative 1, comma negative 2, and the reflection point, negative 3, comma negative 2, would be right here. Go ahead and connect, again, keeping the bottom of your parabola as smooth and as round as you can. It should not be super pointy. And there you go, 5 points. Now, here's another example where the x plus 1 is a positive number. So again, that means for your vertex, we'll take the opposite. So this is negative 1. Keep whatever's on the outside, which is a negative 2. Axis of symmetry runs through the vertex at negative 1. Y-intercept we have to solve for, so we need to plug in a 0. So y equals 2 thirds 0 plus 1 squared minus 2, which is 2 thirds 1 squared minus 2. So 2 thirds times 1 minus 2, we get negative 4 thirds. So the y-intercept is 0, negative 4 thirds, which is approximately negative 1.33. Repeating. So graphing, here's the x-axis, the axis of symmetry at x equals -1. Vertex is -1, -2. And y-intercept at 0, -4/3. So it's 1 and a little bit more than 1 right in here. 0, -4/3. And when we reflect this over, this will be -2, comma, -4/3. We need to plug in one more point. We've already plugged in -1. We've already plugged in 0. Let's plug in a +1. So with a +1, we'll say y equals 2/3 1 plus 1 squared minus 2. Y equals 2/3 2 squared minus 2. Come over here a little bit, so we get y equals 2/3 times 4 minus 2. So this becomes 8/3 minus 2, which is 2/3. So we get 1 comma 2/3 right about here. And again, you may use your calculator to get this value. You can plug this as it is, exactly with those parentheses, and that squares into your calculator. It will give you 2/3 or 0.66 repeating. And we get -3 comma 2/3. And connect. Okay. Now, some of the questions that we often get about the vertex is, wait, is it always negative? Is it always positive? What about the vertex? So just come down here and let's make a quick note. Just right up here at the top of your page 8 notes, or if you have room on the last page, that's fine. But just a quick note that if you have y equals, say, x plus 10 squared plus 3, the vertex will be -10, +3. If you have y equals x minus 10 squared plus 3, the vertex will be +10, comma, +3. It's always the opposite sign for this first one. So if it's a positive, it becomes a negative. Negative becomes a positive. But it always stays the same for these last ones. Okay, these last ones don't change. All right. So that's the end of your 5.3a notes. We'll come back to finish up 5.3b.